Okay, guys, in this section, we are going to talk about properties of logarithms. Well, we are going to start with some examples and then set up actually the property. So we're going to start with example number 1. What is logarithm with base 3 of 3? Well, to which power we'll need raise 3 to get 3? Well, obviously to the power of 1, right? Okay, so the property is going to sound like this. Logarithm with base a of a equals to 1. That's going to be always the case. Property number 2. What is going to be logarithm with base 3 of 1? Well, to which power we'll need to raise 3 to get 1? You probably already don't remember, but there was a rule that 3 to the power of 0 is equal to 1. So if we compare it, we're going to figure out that x is equal to 0. So I'm going to write it down as a rule. So logarithm with base a of 1 is equal to 0. There's going to be one special point on logarithmic graph with coordinates 1 and 0. Okay, good. Now, what other properties? Well, we know that exponential function and logarithmic are inverses. Inverses means that I'm going to write down a to the power of x and logarithm with base a of x are inverses. Means that for them works cancellation equation. Remember cancellation equation. F inverse composition with f equals f composition with f inverse and equals to x. Let's see how it works with these two functions. So I'm not going to give an example. I'm going to just give calculations first, and then we are going to see it in some problems. So I'm going to first do this one. So f multiplied by f inverse composition. So I have to use exponential function a, but instead of x here, I'm going to put inverse function, which is log with base a of x. And it's supposed to be equal to x. For us, it's going to mean that the power and log are canceling each other if the base of log and the base of the power are same. F inverse composition with f is going to be log with base a, and instead of x here, we put a to the power of x, a to the power of x. Supposed to be equal to x according cancellation equation means that log is going to cancel with the power 2. These are called cancellation equations, and eventually we are going to use it solving problems. But for right now, you just remember them. Okay. Well, rule number 4. Rule number 4. What if we have a logarithm with base 2 of a product of 4 multiplied by 8? What is going to be? Well, what we are trying to solve, we are trying to find the power of 2, which is going to give you a product of 4 and 8, right? But 4 is a power of 2 with 2, right? And 8 is 2 to the power of 3. So obviously together they're making 2 plus 3, and they're making 5. So the power of 2 to produce this is equal to 5. Well, guys, 5 can be always represented as a sum of 2 and 3, right? And actually, what is 2 here? 2, it's a power of 4. Actually, 2 is a logarithm with base 2 of 4. This is 2. And 3 is a power of 2 to the power of 3, means that if I take a logarithm of 8 with base 2, well, I'm supposed to get 3, right? 2 to the power of 3 equals to 8. So this is kind of for this 3 and for this 2. So what we can do, guys, from this, what we can see, that you can split a product into the sum of logarithms. For us, it's going to mean that logarithm with some base a of x multiplied by y can be represented as logarithm with base a of x plus logarithm with base a of y. So the logarithm of the product equals sums of the logarithm. A little bit unusual, but we can kind of understand it. What is going to happen if instead of a product, you have a ratio? For example, I'm going to set it as a rule number 5, and you have a logarithm with base 2 of 4 over 8. All of it like not kind of. You can always do a logarithm with base 2 of 4 multiplied by 8 to the power of -8, right? Use the rule. So write it down, logarithm with base 4 plus logarithm with base 2 of 8 to the power of -1. Now, guys, a little bit more to continue. Well, logarithm with base 2 of 4, we know that it's equals to 2, right? But what is going to be here? Well, it's which power we need to raise 2 to get 8 to the power of -1. 1 over 8, or 1 over 2 cube, or 2 to the power of -3. So x is equal to -3, right? Which means that it's minus logarithm with base 2 of 8, because 2 to the power of 3 is 8. We need -3, so it's going to be minus. The conclusion here is that if you have a ratio, it's going to have a minus between logarithms. So logarithm with base, sorry, not supposed to be 2, it's general rule of base a of x over y is going to be logarithm with base a of x minus logarithm with base a of y. Again, because you always can represent a product as a product, right? The fraction is a product, and in the product, y is going to have a negative power. But negative power here is just going to give you extra minus, but the number is still going to stay same. If it was 8 to the power, it was 2 to the power of 3, which is giving 8. The minus is going to be outside. Okay, so 1, 2, 3. Next property is property number 6. Property number 6 is what is going to happen if you have logarithm with base a of some number m to the power of r. How it's going to work? Well, I'm going to use actually the previous formula to do it. Let's imagine that r is a natural number, like 2 or 5 or something. Then what we are going to have? We're going to have logarithm with base a, m multiplied by m multiplied by m multiplied by m, and multiplied by m r times, right? We can always represent it as using the previous formula, logarithm of a m plus logarithm with base a of m r times, right? Oh, just using the previous formula that the sum, the product can be represented as a sum. Now, because they're all same logarithms, we can always write it down. We can always write it down as r logarithm with base a of m. You see what happens here? This r will jump outside of the logarithm and stand in front of it. That's going to be the rule. Okay. Okay. Next rule. Rule number 7. Well, it's not actually a super rule, but you know that we can always represent a to the power of x as e to the power of ln of a multiplied by x. For right now, we kind of don't need it, but eventually in your next class, you probably will need it. What I'm trying to say? I'm trying to say that a can be represented as e to the power of ln of a. Remember cancellation rule. E and ln, natural logarithm, are canceling each other and get a. So what I'm going to do, I'm going to write down instead of a, sorry, I'm going to write down a to the power of x equals e ln of a instead of a to the power of x, and then multiply powers. Well, we're not going to use immediately this property, so if you kind of don't get it, that's fine. Now, guys, I want to do several examples of like calculations with logarithms, and I want you to watch how I do this. So examples. Example number 1. Logarithm with base 5 of 7 plus 4 logarithms with base 5 of 3. And somebody is asking to simplify it. How do we simplify it? Well, guys, we can merge two logarithms with the same base, but we're supposed to have no coefficient in front. What we can do with coefficient? Remember that coefficient, it's actually a power of this. So I'm going to write down it's logarithm with base 5 of 7 plus logarithm with base 5 of 3 to the power of 4. Or logarithm with base 5, the sum of logarithms can be merged into a product. 7 multiplied by 3 to the power of 4. Well, I simplified it. I did not calculate 3 to the power of 4. It's actually 81. But you see that kind of a little bit like different way of writing down the same expression. Problem 2. Well, let's do a little bit longer. Logarithm with base 2 of x plus logarithm with base 2 of 9 minus logarithm with base 2 of 5. If you have three expressions, remember that you can convert the sum into a product of x by 9 logarithm with base 2. And difference is converted into a ratio. So logarithm with base 2, 9x, this is 9, and 5 is supposed to be in denominator because it has minus. So we converted it to one expression. Okay. Well, example of cancellation equation. E to the power of ln of 8. What is going to be? Well, we remember that e and ln are inverse functions, so they cancel each other. Cancellation rule is going to be equal to 8. Well, what else? I'm going to simplify one more expression. And that's going to be logarithm with base 3 of square root of x minus logarithm with base 3 of x cubed. So I'm going to use the rule when we can take a power of x and put it in front. Here it's kind of obvious. The power is 3, so I can put 3 in front. What is the power of here? Well, we remember that square root of x, it's x to the power of 1 over 2, right? So actually we have logarithm with base 3, x to the power of 1 over 2 minus, and I'm going to take this 3 in front, logarithm of x. And now I'm ready to take this 1 over 2 in front, and I'm going to get 1 over 2 logarithm with base 3 of x minus 3 logarithm with base 3 of x. Now, logarithm with base 3 of x and logarithm with base 3 of x are same, so I'm going to take it outside of parentheses. That's 1 over 2 minus 3, which is going to give me minus 2.5, right? Logarithm with base 3 of x. So that's simplified version of my expression. Okay, guys, I'm going to evaluate a couple of logarithms and then teach you one more formula. Well, usually calculators are allowing us to evaluate logarithms directly. Let me use my calculator and see how it's going to show us the algorithm. Okay, my calculator, my cell phone calculator actually, is going to allow me take natural logarithm and decimal logarithm. So for example, if I want to evaluate ln of 10, I'm just going to write down ln on my calculator, put 10 as argument, and that's going to give me a number 2.302 and more digits approximately, right? If I want to calculate log of, I don't know, log of 25, for example, what is log of 25? Let's calculate that. That's going to be common logarithm. So my calculator and your cell phone calculator has log, and then you put 25 as argument and get the number. And it looks like it's 139, 7, and more digits. Okay. Now, guys, some calculators are not allowing you to calculate arbitrary base. For example, what if you want, what I want logarithm with base 2 of 5? Well, my calculator does not have either logarithm with base 2. It has only logarithms with base e and 10. So what should I do in this case? Well, there is actually option of using inverse, but remember, imagine that you don't have this option. How are we going to do it? Guys, there is a change of base formula. Change of base formula. Change of base formula works if you want to convert logarithm with base a of b to a different base, for example, base c. And you copy the b on the top and the base on the bottom and divide them. I'm going to apply it to the formula. I'm not going to prove the formula. I'm just going to apply it to the formula log with base 2 of 5. So it's supposed to be log with 5 over log with 2 in terms of common logarithm. I'm going to just calculate it using my calculator. So log of 5 equals 0.698 approximately. Now I'm going to calculate log of 2. Log of, log of 2 equals 0.301, and the ratio between them, give me a second, log of 5 divide over log of 2. The ratio between them is 232 more digits approximately. So you see, if your calculator does not have directly the base, like arbitrary base like 2 or 15 or whatever, then you can use a standard base, which is usually either ln or log or both of them usually are represented in your calculator. Okay. Okay, that's it for logarithms and properties of logarithms. And don't forget to do your homework.